Running AI models fully locally has become quite practical on modern consumer hardware. And if you do any agent encoding, you've probably noticed just how much of it runs in parallel. But a single machine can only do so much at once. And the moment you've got several agents going, you hit the ceiling fast. However, if you have more than one machine at your disposal, you can raise that ceiling. And I don't mean manually using two different computers at the same time. I mean actually engaging a sort of at-home or at-office horizontal scaling and creating a local AI cluster that can power up your coding assistant. And that's what I want to show you today. We need three things: a coding assistant, something to connect the machines and run inference, and an open weight model, ideally one that supports function calling so that the assistant can actually do things. For the assistant, I'll use OpenCode, a very popular open source coding agent. Like its commercial alternatives, you can run it as your favorite IDE extension, a desktop app, or in the terminal, which is what we'll do today. To connect the machines and run inference, I will use Paddler, our open source LMOps platform for self-hosting models. Normally, you'd spread it across many servers to serve a lot of users, but the same mechanics work just as well across the machines in your home or office. For the model, this Qwen 3.6 is a good fit. Powerful, but still able to run on a lot of consumer hardware. Hugging Face is the usual place to grab it, and we won't even have to download it ourselves. Paddler does that for us. So let's put it together. I'll start on my laptop. First, I start Paddler's balancer with a few services running locally. There's the inference service, which is Paddler's own API for generating tokens. There's the OpenAI compatibility service, which we need because OpenCode speaks the OpenAI API format. And there's the web admin panel, so we can watch what's happening in real time. I also expose the management service on my network address so that the other computer can reach it. I will use this laptop to generate tokens too, so I start an agent pointed at the balancer and give it a couple of slots. A slot is like a unit of work, how many requests this machine can handle at once. And I can already see the small setup in the web admin panel. Next, I point OpenCode at Paddler. This part is that simple. In its config, I add Paddler as a custom provider and point the base URL at Paddler's OpenAI compatible endpoint. I can drop this config into each project as an opencode.json or put it somewhere like this location to have it available everywhere. The model name in the config is just a label. Paddler is going to use whatever model is actually loaded in the cluster. And loading that model is something I can do straight from the web admin panel. That's it. There's still only one machine, but the setup is ready to go. So I can test it, and here's where it gets interesting. I can start several tasks at once, and they quickly fill the slots, and the rest of the requests stack up in a queue. You set the number of slots based on how many requests a single machine can reasonably handle at the same time. The other requests aren't rejected, they're buffered, waiting their turn for a free slot. And this is exactly the ceiling I described earlier. One machine doing what it can and everything else is waiting. So now I bring in my second machine. I run the same agent command, again pointing at the management service running from my laptop, and watch the dashboard the moment it connects. The new machine appears, the queue drains, and the work gets spread across both computers. Some tasks on the laptop, some on the desktop. I didn't reconfigure OpenCode, and I didn't restart anything, I just added a machine, and the cluster started balancing the load on its own. Now, it's worth being precise about what it actually gives you. Adding more machines doesn't make a single conversation faster. What it does is the ability to do more work at the same time, run more agents, work through different code bases, and so on. So if your work is naturally parallel, that's the real benefit. At home, it means putting an idle machine to work whenever the main one isn't enough. In an office, it's arguably even more compelling because a team can pull all of the machines they already have into one single private AI cluster without a single line of code leaving the building. I hope this video was helpful. I will put the links to everything I used in the demo in the description box. And if you have any questions or you want to share your own experience running models locally, leave a comment and follow for more videos like this one.